Welcome back. Problem number 2422. Merge operations to turn array into a palindrome. So you are given an array called nums consisting of positive integers. You can perform the following operation on the array any number of times. We should choose any two indices, any two elements or any two adjacent elements and replace them with their sum. For example, if we have this array 1, 2, 3, 1, we can apply the operation and make it 1, 5, 1. And we should return the minimum number of operations needed to return the array into palindrome. So if we have this one as an example, the output should be 2. The minimum number of operations should be 2. So we can turn the array into a palindrome, and the palindrome means it's an array that when you read it from the beginning to the end, it will be the same if you read it from the end to the beginning. So if we have an array that has 3 elements, 1, 5, 1, if you read it from the beginning, you will read 1, 5, 1. If you try to read it from the end, it will be as well 1, 5, 1. So it will be the same. So from this one, we know how the palindrome works and how it looks like. So we need to find any. We need to look at any array and see how many numbers can we add to this. How many operations we can add to this array to make it as palindrome. So in this one, it will be only 2 because we can turn the array into a palindrome in 2 operations. First, we can apply 2 to 1 here, so it will be 3. So we have 4, 3, 2, 3, 3. And we can apply this one to 3, so we have 4, 3, 2, 3, 4. So let's talk about how we will do this in the actual code. So if I guess most of the palindrome problems will be solvable if we used a 2-pointer solution. So how the 2-pointer will work? Let's get the pen first. So to solve a problem of transforming an array into palindrome with the minimum number of merge operations, we need to understand the nature of operations and how they can help us achieve the goal. So let's just try to break it up. So first we need to understand what is a palindrome, and we said a palindrome read the same forward and backward. For an array to be a palindrome, so if the array should be a palindrome, the nums of I should equals its opposition. So it will be this one. But what is the index of its opposite, or the other element in the index in the end? So it will be, for example, let's say that 4, it will be nums of I, n of I, for example. So it should equals n of I f of n minus 1 minus n minus I minus 1. So any number should be equals to the number at this index. So any number at this index should equal any number at this index. So let's talk about the operations. Let's just delete everything here. So we can merge 2 adjacent elements into their sum. This operation can help us to make the ends of the array match. So for example, we have 4 and 3, so we can just put them together. We have 4. When we have 4 here, the ends match. We have 2 and 3, so we can merge these together. We will have 3. So we will have 4, 3, 2, 3, 4, and it will be a palindrome. And in this one, we can find a 2-pointer. So we can use a 2-pointer, left starting from the beginning and right starting from the end, of the array, we will compare elements of these pointers and decide on operations to make them equal. Let's just try to do this in code. Let me open this in the code. So I said that we will use a two-pointer solution. So we had left, and the left will equals 0, and we will have right, and the right will equals nums dot length minus 1, and we will have the operations that we will return at the end, which will equal 0. And it's quite important to just return the operation from now, because I always forgot to return the actual variable. I will create a while loop, and I will say while left is less than right. Okay. I would say if nums of left equals nums of right. If that was the case, I guess that means we don't need to do anything. We just continue in the loop. So left plus plus and right minus minus. Okay. Let's see if they doesn't equal each other. So let's say else if the nums of left is smaller than nums of right. Let's just copy this one. What we should do in this case, we said a palindrome, we always want to expect that any number on the left side will equals the other number on the right side. So if they are equal each other, we don't have to do anything. It's going in the direction we already wanted to. But if they doesn't equal each other, we have two solutions. We have two options. The one is that, or we have two cases mainly. So the one when left is smaller than right, and the other when right is smaller than left. So when left is smaller than right, I would say nums of left plus 1. Oh, plus 1. Nums in the left side plus 1 will plus equal nums of left. Okay, and we add left by 1, and we add operations 1 because we did one operation. We add the sum. So if the left, for example, was let's say that if the left was let's take something when left is smaller. Yeah, here as an example. So if we take this array as an example, we have 1 and 4, and 1 is really smaller than 4. So what we will do, we will add one operation. We add nums left plus 1, and we add it to left. So we add 2 plus 1, it will be equals 3, and we increase the operation by 1 because we did one operation. If that wasn't the case, that means the right is smaller than left. We will do the same. So, but it's quite important to know we will not do right plus 1 because right is already in the end. So if right was plus 1, it will be outside of the actual array. So we say nums of right minus 1 will plus equal nums of right, and right will be minus minus, and the operations will be increased by 1. Okay, and I guess that's it. Let's try to submit the code and see how it will work. It did work, and we're beating 77% of all the codes. But let's look. Yeah. Okay, so our code take 70 milliseconds, and the best approach take 60 milliseconds. So it become to like a bad internet or something like that. But like if the time wasn't huge, you don't have to worry about it that much. So let's try to break down the solution again. So here, let's look at this one. First, we have initialization. So we start by setting left to the beginning and of the array and right to the end. We initialize the operations to 0. And this one will keep track of how many merge operations we did perform. We have a while loop here, and the loop runs as long as left is less than right. After that, also inside the loop, we compare the elements at the left and the right pointers. We have the comparison and merging here. This is the comparison and merging operation. So if left is equal to right, it means the elements are already matching for the palindrome. So we simply move both pointers inward. If left is less than right, it means that the element on the left is smaller. So we merge it with its neighbor on the right and move the left pointer inward. If nums of left is greater than nums of right, and it means the element on the right is smaller, so we merge it with its neighbor on the left and move the right pointer inward. After each merge operation, we increment the operation counter, and after that we return the result here. After the loop finishes, the operations will contain the minimum number of merge operations needed to make the array a palindrome. And yeah, that's it for this solution. And yeah, I hope you like my solution. If you have any question, feel free to ask. And yeah, that's it.